We're going to take a look at factoring polynomials of the form x squared plus bx plus c. So what we're looking at here is that there is no number in front of x that's squared, that it's just a 1x squared. Just to review a little bit of expanding, looking at foiling, you can use two different strategies here. I used the chart method and foiling. You could use also algebra tiles, don't forget. Regardless of how you do this, you should get 15x squared plus 26x plus 8. So we're going to look at algebra tiles and what these trinomials look like as algebra tiles. I'm just going to quickly draw them in here. Okay, so I've drawn in some shoddy looking algebra tiles here, and we're just going to quickly color them in as the trinomial looks like. So for the first one here, all three of our terms are positive, and remember x squared is the big X here. And then we have 4x cubes, so we'll color those in positive as well, and then 3 1's cubes. In my next example, again, all of it is positive. We have an x squared cube, 3x cubes, and 2 1's. This next one is a little bit more confusing. So we have an x cube, and it's really clear that we have 6 negative 1's here. Now we need to, out of the 5 squares here, put in 1 positive x. So what that means is I need to have 2 negatives and 3 positives. So we're going to color them in their groupings that way. So I won't color in my 2 negatives and 1 positive here. That doesn't really make sense. We're going to try and color in 2 negatives that are together and then 3 positives that are together. So again, a positive and a negative would cancel one another out. So in this case, we would have 2 negatives cancel with 2 positives, and we're left with 1 positive yellow x cube. Our last one here is an x squared. We have negative 6x, so 6x cubes that are red, and then our 1's cubes are all positive here. So what we're going to look at is the width of these. So I'm going to say that this length will be my width. When I look at this, I have an x length and a 1 length. So my width is x plus 1. Same thing in this direction for this set of algebra tiles. I again have an x plus 1. In this setting, I have an x, and I have 3 1's here. So I have x plus 3. And the last one, we have an x length, and we have 2 negative 1's. So we'll have a negative 2 there. Following along that same line for each of the tops here, I'm going to get an x plus 3. X plus 2. I have an x take away 2, again, because these 1's here are negative. And then I have an x minus 4. So the factored form of the width times the length that describes the area of these algebra tiles is x plus 1, x plus 3, x plus 1, x plus 2, x plus 3, x minus 2, and x minus 2 times x minus 4. So we have factored each of these polynomials by using our algebra tiles to determine a length and a width that multiply together to create this. So the trick with this is when we are arranging our algebra tiles, they must form some sort of a rectangle here. So answering the questions on the next page, the first term in the trinomial, so this one, and the first term in the binomials. The first term in our trinomial here is the first terms in our binomials multiplied together, an x times an x. And that's the case in every one of these because they're all just 1x squared, and we all have an x, just no coefficient in front of it, a 1x, sorry, in each binomial. The coefficient of the middle term in the trinomial, so the 3x, 4x, positive x, etc., and the second terms in the binomials. The coefficient here is 4. The second terms in my binomials add to 4. Here, 3x, the second terms in my binomials add to 3. Here we have a positive x, positive 3 and negative 2 add to 1, and negative 6, negative 2, and negative 4 add to that number. And the last term in our trinomial here, and the second terms in our polynomials, our last term is 3. 1 times 3 is 3. Our last term is 2. 1 times 2 is 2. Negative 6, positive 3 times negative 2 is negative 6. And positive 8, negative 2 times negative 4 is positive 8. So the last term in our binomials multiply to become the last term in our trinomial. So the rule for factoring a trinomial of the form x squared plus bx plus c, what we're going to end up with is an x plus g times an x plus h, where g and h are numbers, okay, or integers, I could say even. So where, and again, this was for x squared plus bx plus c, where g plus h equal the coefficient b, and g times h equal the coefficient c. So factoring and expanding are inverse processes. Expanding was like foiling. Factoring, we're going to take our x squared plus bx plus c and create factors of x plus h and x plus g. Okay, so factoring is finding those two binomials that multiply together. So we need to find two numbers that multiply to 15. That's usually where I start because there's fewer numbers that multiply to 15 than add to 7. So 15 can be found using 15 times 1. We could also use negative 15 times negative 1. We could use 3 times 5 or negative 3 times negative 5. Okay, so don't forget for a positive number, we can have two negatives that come together to become that. So out of these options, I'm going to test what these add to. So these multiplied to 15, and we're going to see what they add to. So 15 plus 1 would be 16. Negative 15 plus negative 1 would be negative 16. 3 plus 5 is 8, and negative 3 plus negative 5 is negative 8. So we're going to choose the two numbers that both multiply to 15 and add to our coefficient 8. So 3 and 5 are the numbers we're going to use then. So we're going to factor this to x plus 3, because we're using the positive 3, times x plus 5. Now, if we're not sure about this, we can always go back and check our work. So let's FOIL just to check. So our first terms multiplied is x squared. Our last outside terms multiplied is 5x. Inside is 3x and plus 15. Add those together, we get x squared plus 8x plus 15. We've done it right. For example B here, I'm just going to rewrite it in the format that we're used to. Again, that is x squared plus bx plus c. So I'm going to pull the a squared first, and then the 7a and negative 18. So we need to find values that multiply to negative 18 first. Okay, so we could use, by multiply to 15, we could try always negative 1 and 18. We could also have positive 1 and negative 18. Just be careful because these add to different things, so it's important to consider both options. We can have negative 3 times positive 6, positive 3 times negative 6, and negative 2 times 9, and 9 times negative 2, and positive 2 times negative 9. Those are all the options. Let's check what they add to. We get 17, negative 17, positive 3, negative 3. We get 7 and negative 7. So because our middle term is positive 7, we're going to use those two numbers. So negative 2 and 9 are the values we're going to use. We don't have x's here, we have a's, but that will work the same. So a, and we're going to put in a negative 2 and a positive 9. Again, we could FOIL to check. We could also write this as a plus 9 times a minus 2. It's like writing 3 times 2 equals 6 or 2 times 3 equals 6. It doesn't matter the order of those two. Same thing with our binomials. So factor these completely. What I noticed first off is that there's a number in front of my x squared, and I can't work with that at this rate. So we need to try and remove that as a greatest common factor. So I'm going to try and factor out a positive 4 from the entire trinomial here. So I'm going to divide each coefficient by 4. And I'm going to get x squared minus 6x plus 8. So the first step was to remove our greatest common factor. Then we are going to factor what's left in the brackets. So two numbers that multiply to 8 and add to negative 6, negative 4, and negative 2. Multiply to negative 8 and add to negative 6. You're going to get a little bit quicker at picking these. If making a multiplication table or like a table of values to organize works for you, go for it. So the 4 is still out front, and then I've factored this trinomial into two binomials. So it'll be x minus 4 and x minus 2. So for b, I'm going to rewrite it in the proper order first with my x squared term first. So negative 5h squared. Next will be just my h term, so minus 20h. And plus 60 is at the end. Now again, I cannot start with a negative 5, so I need to take out the negative and the 5. It has to be a positive x squared plus bx plus c, whatever our variables are. Here we have h's, but we cannot have a negative x squared. We have to start with a positive. So I'm going to remove that negative 5. Therefore, I'm dividing every term by negative 5. I'm going to be left with h squared plus 4h. And the reason is we had a negative 20 divided by negative 5. That gives me a positive 4. Positive 60 divided by negative 5 is negative 12. Now, values that multiply to negative 12 and add to positive 4 are positive 6 and negative 2. So our negative 5 remains out front. And our trinomial has been split into two binomials where we have h plus 6 and h minus 2. Again, if you're unsure, go ahead and FOIL this out. So we'd get negative 5, and then there'll be h squared minus 2h plus 6h minus 12. We can combine our middle terms, so negative 5h squared plus 4h minus 12. And last but not least, we'll multiply in our negative 5. So I get negative 5h squared minus 20h plus 60, which is what we started with. Example 3 here looks a little bit tricky because we have x's and y's, but we're going to deal with the coefficients as we have before. So positive 6 and negative 8, two numbers that multiply to positive 8 would be 4 and 2, and they add to 6. So the only thing that's different with our variables is that we have an x and a y. So we have an x in one term of our binomial and a y in the other. And the coefficient in front of y just becomes our two numbers here. So positive 4y and positive 2y. Now I'll show you again. We'll FOIL it back out just to double check our work. So we're going to get x squared plus 2xy plus 4xy plus 8y squared. And collecting our like terms here, we get plus 6xy plus 8x squared. which is what we started with. So if there are multiple variables, we're going to separate them in the binomial. All right, let's factor x squared minus 5x minus 14. So I ended up with x minus 7 and x plus 2. Again, because negative 7 and 2 multiplied to negative 14, and they add to negative 5. Now over here, the only difference is the sign of our middle term. So two numbers that multiply to negative 14 and add to positive 5 are x plus 7 and x minus 2. So changing the sign in the middle of, for the middle value or term, in our polynomial, we'll just switch the signs within our binomials. Okay, so same values, 7 and 2, just opposite signs. Find and correct the errors in factorization. So looking here, negative 6 and negative 2 multiply to be positive 12, so that looks good. But negative 6 plus negative 2 is negative 8, and that does not equal our middle value here. So two numbers that multiply to positive 12 could be 12 and 1. And to get them to add to negative 13, if I use negative 12 times negative 1, that's still positive 12, but they add to 13, negative 13. So we're going to use x minus 12 and x minus 1 to be the factor for that polynomial. Over here, I'm just going to rewrite this as x minus 4 times x minus 4. I find it easier to look at. So negative 4 times negative 4 is equal to negative 16. And that is not our value for C. So that's a problem. Negative 4 plus negative 4 worked out to be our middle term though. So our problem lies within that last term. Two numbers that multiply to negative 9 would be maybe negative 9 and positive 1. And they add to negative 8. So x minus 9 and x plus 1 will be our factors here. The exit task here is to factor x squared plus 5xy minus 36y squared completely. Give that a try. We should find two numbers that multiply to negative 36 could be a bunch of different things. So let's make a little table again just to show. So negative 36 is what we want to multiply to. We could have 1 and negative 36, negative 1 and positive 36. We could have 2 and negative 18, negative 2 and positive 18. We could have 3 and negative 13, negative 3 and, 13 is not what I want, negative 12, sorry. And positive 12. We could have positive 4 and negative 9, negative 9 and positive 4. And then we could have 6 and negative 6. I think those are our options. Now looking here, I can quickly identify what might become close to positive 5. So this would leave us with negative 35. This would be positive 35, negative 16, positive 16, negative 9, positive 9. Here we are at negative 5. And oopsie, I should have had positive here. And positive 5. So this looks to be the right combo, the one that I mixed up before. So we need an x and a y in our binomials here. Okay, so we're going to have x plus 9y and x minus 4y. Again, if you're unsure, let's FOIL it out. So we get x squared minus 4xy. Next up, we're going to have plus 9xy and minus 36y squared. Combine these two central terms and we get positive 5xy minus 36y squared.